mic on a mic stand. I feel like I'm going to sing something. Not really. You all had a good lunch break? It's good food here, isn't it? Everyone got good portions of everything. It's always good to check. Cool. So this afternoon's talk in this room is from Tim. So I want to introduce you to Tim. I'm going to be talking about attackers attacking our data and keeping our APIs safe. So yeah, hopefully you should all learn something new. And introduce you to Tim. Thank you, Tim.
I want to thank you all for coming. I'm very flattered to see not very many empty seats. So my name is Tim Bond. I'm from Seattle. I work for McGraw-Hill, the company that you probably remember seeing the red logo on in your textbooks back in the day. We're mostly digital now, and so I get to work on our fun authoring platform. And we do have a lot of APIs, and that's partly what I'm going to talk about. So I started my PHP development back in 2004. I thought it would be a good idea to learn a programming language, and PHP was all the rage at that time, so that's what I started working with. Fast forward today, I'm still working with it. I develop a lot of APIs for my job. I consume them as part of my job, and just for fun in the free time to get data that I like. I'm a front-end developer when I have to be, but I don't really consider myself so much as a front-end person. I very much enjoy all the back-end. I am not a lawyer, I'm not a security expert, I'm not a penetration tester, although it might kind of sound like it after we get through some of this. I don't know everything. This talk is really just going to be about things that I've seen and things that I can talk about. And when I say that, we have a law in the US that prohibits anyone from decompiling or decrypting someone else's application. And so theoretically, what I would be able to talk about is not something I could ever have done. So we're going to talk about maybe some laboratory exercises that I did, and definitely not any live applications out there. So like I said, a lot of that comes from mobile apps that I use, although a lot of this information is still going to be applicable to web APIs that you might use or see in a browser, and also machine-to-machine applications. So for example, when you have one web service call another to get some data. So this is not going to be a hacking workshop. I'm not going to go through some of the apps that we would use to go and attack someone's app. I'm not going to be able to answer every single question that you might have about API security. I don't want this to be the only thing you ever think about API security. I'm not really targeting what I would call a SaaS API or a software as a service. So if you think about companies like Stripe or Twilio, where their business is selling their API, that's a much different security talk than we're talking about this. And I want to think about more where you use an API as through the course of your business to run your business, and not so much that it is your business. So I mentioned some of the APIs we're going to talk about. So just to make sure that we're all on the same page here about what we would consider an API, your web app might have some APIs that it would call to get data for the user. Definitely mobile apps are always going to be interacting with APIs to get to the data from various services. But I don't want you to overlook AJAX endpoints that would just be powering a website. Although those aren't typically considered an API, it can be used to get data in the same way. Also, partner integrations and internal integrations. This is kind of those machine-to-machine APIs that I was talking about. Internal integrations are one you want to be especially careful about because it's usually an API that you might use with another team to help support another application. And then maybe one of your customers wants to have access to the data, and then later you decide, oh, we'll just make that API public. And when it was easy and you could just talk to the other developers down the hall, the security implications were a lot less than when you're all of a sudden exposing that out to the internet. Also, in some ways, we consider a web page to actually be a form of an API, which we're going to talk about at the very end. So why would someone go and attack your API? It could just be that they want to know some more about what kind of data you have out there, or it could be that they're trying to get somewhat of a copy of your database that your API is powering. It could be one of your competitors that wants to know more about your customers. It could be someone that has a grudge against you, maybe for firing them, or potentially one of your customers that wants to overtake you. Another is that there's just no other way to get some of the data that you might have as your company. For example, if your company collects a lot of data and processes things, and you're really the only person in the industry that has that, they might go after that because that data is then valuable because you have it. Another really popular one is people trying to build robots against your data. They might then go against that API to go and get that. This is another interesting one that a friend of mine experienced, in that he wanted to sort of run analytics on a company's data, and so he applied for an API key, and they rejected him. And so what he ended up doing is using the API key that was on the company's homepage for a demo of the API to then continue to do that. So, and lastly, to automate repetitive tasks. And I can't mention automation without showing the XKCD for automation. So yeah, this graph is more relatable to me than I feel like it should be. So I know we're just after lunch, and if some of you might want to take a snooze, just listen to this slide, and then you can have a snooze until the end of the talk. So if there's anything you want to remember, that you should limit your API responses to have only the data you need to make your application work. And only who needs to see that data should be able to be seeing it. One user should not be able to view another user's data. With this, you want to have some ongoing monitoring, both automated and human-assisted. So for example, if there's a spike in traffic, that should be waking someone up in the middle of the night, and using my very favorite app on my phone called PagerDuty. So code bugs are definitely responsible for the vast majority of all sorts of leaks that come through with APIs. So usually these types of things, when there is a breach, they're not very well discussed because a company doesn't really want to admit that they were at fault or exactly how the data was breached. But we do know that in 2018, there was a breach from the Google+ social networking site. And in that, there were over 50 million users whose data was leaked. And the information that was on there is the information that you would see when you would visit someone's profile. So with Google+ being a single-page app, you go and click on someone's name, it brings up their profile and some information about them. Well, this was the AJAX endpoint that was on there. The problem with this was that someone found out that you could just put any ID in that same endpoint and just iterate through their entire database and get a list of everyone who had signed up for this. They did not have any sort of protection on there, and that's how someone was able to basically get a copy of the database without having to hack into their servers and export a copy from the actual database. So let's take a look at a mobile app that a business might have, and sort of go through how we would go about attacking that if we were the attacker. So for this particular app, it belongs to a retail store that sells goods in their store. And if you go around with this app, you can scan the barcodes on various different products, and if you scan 10 of them, the shop will give you a $2 or £2 coupon. And so we see when we open up the app, we have all the items in there that we can scan. We'll hit the scan button on one of those. It'll bring up that with the camera. We scan the barcode, and then that counts towards one of our 10. And so you might think, this is a mobile application. It's not like I'm in my browser where I can open the developer tools and see all the requests going by. And so it probably doesn't matter what's in there because nobody can see it. But it's actually quite easy to get access to seeing what's actually being transmitted over the wire. So the first thing you might do is you would set up a packet sniffer. So if you've ever used Wireshark, that'd be a good start. The thing is with Wireshark is it's not going to be able to decrypt any of the HTTPS stuff. So if the API was just over plain HTTP, all the packets would come through, and that would look just great. So the countermeasure for that would be to upgrade your API to use HTTPS. So that way, if someone was using a packet sniffer, they would just see those TLS packets going by. And while that is technically decryptable, the amount of work that it is to go through and do that is sufficient that for pretty much everyone using the web, they would consider that to be a non-issue. So if you then have an HTTPS API, well, what's the attacker going to do next? Is they're going to set up a man-in-the-middle attack. And what this means is they will set up a proxy server, either on the device or on a separate device that it connects to. And the app will connect to that proxy instead of directly to your API. And the proxy is exposing its own secure certificate, and it's then able to decrypt the request that it's getting from the API, and then it will then forward that back onto the API. This will allow you to really see the entirety of all the traffic that's going through. So the countermeasure to this would be to use certificate pinning. And what this means is in your mobile app, you would store a copy of the public key of that certificate. So that way, when the app makes the request to that server, if the public key doesn't match, it will then reject the request, and it won't actually make that connection. This is only a thing in mobile apps. This used to be an option in browsers, but it had been removed because there were too many security implications with people sending forged headers across and making this pretty useless. Of course, we can always bypass that certificate pinning by using some instrumentation on the device that would intercept those calls and tell it not to actually do that check to see if the keys matched. So to counter that, we might do some dynamic integrity checking, which would mean that the app at runtime would go through and it would look at the environment that it's running in and see if some of those libraries that do those checks, maybe we'd take all the code that's compiled and do a SHA sum of it and then compare that to a known value, sort of a code signing. Also, on an Android device, if the device has been rooted, this is primarily the way that you're going to be able to do that instrumentation on there. So you could check to see if the device had been rooted. Some of the most popular apps out there, like Netflix and Pokemon Go, actually do check when the app starts up to see if the device has been rooted, and if it has, then the app just flat out will not run. I caution this because there are kind of two things around that, and that one is that not everyone roots their phone because they want to hack. Some people might be running old, unsupported hardware, or old hardware that is no longer supported by the manufacturer, and so they're running a third-party OS so that they can continue to receive security updates from the OS. And also, there was a package on Android that when you installed it to gain that root access, one of the things that would happen when the app checked to see if the device was rooted, the root app would then look at the package name of who is requesting to ask if I'm rooted, and if it was for, say, Netflix, then you would say no, but if it was maybe the ad block software, you would say yes. So that is also something that could be gotten around. So let's say that we did have that man-in-the-middle attack running, and we were able to watch the traffic. So we'd then open the app up, use it as we normally would, and kind of see some of the requests that are going on throughout the app. And so we can see in there, there's a few different things. We have a call to get some items, another put request for when we scanned in items, and some analytics. So let's say if we looked at that request for the get items, let's say it's a simple endpoint that just returns a list of all the items that are going to be available in the app, having both the title of the item and the EAN of that particular item. And then on that put request, we would see that maybe it had the user ID and a latitude and longitude. That way, we would assume that the server would then be parsing that latitude and longitude and comparing that to the list of the stores and making sure that the user actually is within reasonable range of the store and they're not just sitting at home scanning barcodes. So we also notice that this API has no authentication, so that makes it really, really easy to then go and work with. We see that there's some analytics in there, but we can probably ignore those because it's not going to be critical to actually doing our attack on there of pretending that we scanned items that we didn't actually scan. So like I said, when we open the app, we get the list of all the products that are there. And we could just iterate over that list and send 10 different put requests, and it would be like we walked around the store scanning everything without having to actually do anything. We could put this in a cron job and run it every morning, so that way you know that any time you stop by the shop that you'd always have a coupon available for you when you open up the app. You could do the same thing. You could get your friends' user IDs because those were sent in the clear in there, and so you could set up 5 different cron jobs and make sure all your friends get coupons because you're the generous person that you are. So after we take a look at those routes and we look at that, we start looking at other things. Now we notice that this is a RESTful API. And we like RESTful APIs because the routes are very easily predictable. But the attacker's also really going to love that too because it's just /API/whatever the thing is in there. So we might try and look at some other routes like get user and put in the user ID to see if we can get some information about ourselves. Or maybe we try something like /users to see if we could get a list of all the users that have signed up for this app. Then we might check to see if there's documentation available. This would do 2 things for us. Not only would it tell us all the routes that are going to be available to us, but it's also going to give us some insight into the business logic. For example, the documentation might state that users could only submit 10 put requests in a particular day, and so you wouldn't then bother sending more than 10. We can also try typing in a route to the API that we know doesn't exist, just mash on the keyboard in there, and see if we can get a stack trace or some sort of error page that could reveal what programming language the API was written in, or maybe the framework. And then you can then look at that framework's documentation and see if maybe there's some special routes that that particular framework offers that would then give you access to maybe the entire routes list or debugging parameters or other things like that. So like I said, we noticed there may have been a route called get user and based on the ID. So we wouldn't want someone to just go through and type in every single user ID that's in there. So on this, it's a good idea to use a rate limiter if this is a particular route that is going to be a valid use for your users. So maybe in this app we have a section where people can view other users, and maybe there's a leaderboard that shows all the different users in there. So we might want to be able to have someone view the profile of another user, and so they could potentially need to hit that endpoint to get that basic information about the user, such as their name and photo. But we wouldn't want someone to go through and iterate through the entire list, so we would want to install a rate limiter on our application to make sure that users aren't calling that too frequently. We're going to talk about rate limiters a little bit more later. This is also a good case for using UUIDs to look up any sort of record, not just user records. So if we notice that our user ID is 123, there's probably a good chance that there's another record at 124 or 122. But if you use a GUID for that, it makes it much, much more difficult, though still possible, to guess someone else's user ID. And I know with PHP, MySQL is a very popular database to be used, and MySQL makes UUIDs a little bit more difficult than it really should be. So that doesn't necessarily mean that you need to get rid of your auto-incrementing integers for your primary keys right away. You can store a UUID in a column adjacent to that and still use those indexed as lookups, and then internally do your joins based on your integer IDs. So let's say that our our application code looks something like this. So we have a route for getting users by their ID. And I know this is going to look different in every particular framework, but generally you'll have a controller method in there that would be named based something on the route, and it's going to have a parameter that takes in the ID. And so in this case, it might just pass that ID directly to the database, which is going to perform a select on that, return that as an array or object, which then the framework would then serialize out to JSON or XML or whatever the API happens to use. This is not a very good idea because this means that anyone with any ID can call this, and it's going to return all the information that that get user method is going to be in there. It might be a select star, and so that could even return a copy of the hashed password because we're all storing passwords hashed and definitely not in plain text. So a better way to go around this would be to use view models. So in this case, we have the same call to get the user's information. We'll store that in a variable. And next, we're going to look up and see if the currently logged in user is sort of a super user, someone who really should be able to see a lot of information about all of the users. And so if it is, we're going to create an instance of this, something that we're going to call an admin user response. And this is going to have a list of all the particular keys that that type of user should see in there. So maybe an admin user would have a legitimate use case for seeing the created date for this user record, whereas most other people wouldn't normally have that. So if you were then, if the current user was the same as the ID of the user that we're looking up, we would still return the same thing, but it may omit some of those keys that the admin user would have. And lastly, if they're not an admin and the user ID does not match, depending on the scope of our application, if it's something where other users do need to see something in there, then you would have maybe another response type which just has a couple of those keys that they absolutely need to see. But if it's something where users don't ever need to see information about each other, then at that point, you would want to return an exception on there and give them an HTTP 400 and say, hey, you're definitely not allowed to look at this. So by doing this, you can kind of encapsulate some of your logic into these view models and not have to worry about each particular API endpoint having to check to make sure that the right keys have been redacted. And also tests are something that are really, really, really important to catch some of this, because especially when you have new developers on your team, they might need to add a data point on one API, and they might not recognize that that's also being used on a lot of other things. So if you have tests asserting that your API output is exactly this structure, and then all of a sudden there's a new key in there, the test will fail, and your developers will know that something is wrong, and we don't want to be exposing new data in there. You do have to be really thorough on this, especially on endpoints that will do something like searching, and you have different query parameters that they could pass in to return different records. Another thing that you can install, this can take place sort of in place of your load balancer or possibly sit between your load balancer and your application, is something called a web application firewall. And what this will do is it's going to look at all the requests coming in and look and see what the user is putting in those requests. And it can catch a lot of the low-hanging fruit for something like SQL injection, because those tend to have some very predictable strings to see that the user is adding semicolons and a quote and then maybe a drop table or something like that. And if it saw something like that it was able to detect, it would then just completely reject it, and this request would not even get to your API. There is, of course, some limitations to this, and they are only able to react to what they've been trained to react to. So this doesn't mean that it's a substitute for actual good application security in there, in your actual application. So definitely, parameterize your inputs for SQL queries and things like that. But these are really good and at catching some very common attacks, and they can also mitigate against the script kiddies who will try every single vulnerable URL that has ever been published. Such as looking things like /phpMyAdmin or WordPress vulnerabilities and things like that. And so that can actually stop things from getting into your application and hopefully make you not have to wake up in the middle of the night for those PagerDuty alerts. So like I mentioned in this API that we're working at, it didn't have any authentication, so we should probably add that in here. So the first thing you might think of when you think of authentication is either auth basic or auth digest. And these are basically requiring a username and password to be able to make the request. This doesn't actually change the security of anything in the payload. It really just means it's an extra part of the URL that you have to put in there. And so that's not really a secure method, a lot of times also because these are just static usernames and passwords that would be given out to everyone that would be then consuming this. So I would not consider this to be a valid method of authentication for the API. It does mean that anyone who happens to know the URL won't be able to call it unless they have that username and password. But again, it's definitely not very secure. So a very, very common method for securing APIs would be an API key. And these are usually some sort of static string, and then depending on how things are set up, you might give one to your Android application, another one to your web application. But it's going to be a fixed string in there that's just going to allow anyone with that API key to call pretty much any endpoint for any user's data. In some cases, you might have like a partner or a user key, especially if you're having an internal API or something that's an API that you share with one of your business partners so that they can then access your thing without having to deal with cumbersome authentication. You might know those as application API keys, especially for mobile web or mobile apps. But static API keys are incredibly insecure. Because they are very difficult to rotate, it means that anyone who gets one can then call your API as much as they want. And especially if you have those in use on one of your production sites, it would mean that if someone got a hold of that, was making a bunch of malicious requests, you would not then be able to deactivate that API key because it would also deactivate all your legitimate users who are then using the application. You should consider that an API key is compromised the very first time that you use it. It's very possible that there's a proxy server in the middle of someone's request that could cache that URL in there, and then that API key is then going to be part of the server logs on there. If you're looking for the source code of an application, they're generally very easy to find because they'll be named something like API key. And like I mentioned, they're hard to rotate because once they get out there, they tend to be used over and over and over again for many users at a time. API keys are also something developers tend to hard code in their code. This is just me going to GitHub and searching for API_key, and we have almost 7 million records. Now, I've given this talk before in late 2021, and I had this same screenshot in here, and there were about 4.5 million, so I guess people were getting really good at committing API keys still. So another form of authentication we could use is token authentication. And so what we do is we'll assign a unique string to each user. So when they log in, as soon as we've validated their credentials, we're going to generate some sort of string, and we're going to assign that directly to a user. Even better is if we can assign a unique token to each user for each session that they are in. So if they have maybe a web session going and an app session going, they would have different tokens for each of those. Each token is going to have a defined TTL, or time to live, which means that the server is going to know that after a set period of time that that token is no longer going to be valid. The server would be able to revoke or extend that at any time. So if we see some suspicious activity with one of these tokens, we could just say, hey, we're going to cut that one off and it's no longer valid. Or maybe if the user ticked the remember me and their traffic looks normal, we can continue to extend that token for several days or hours at a time. In a way, we could think of this as a per user API key. So now when we start getting requests coming in, we can start to identify which user is making the request, versus before, if we had a static API key, we just know that a user was making a request. So in the infancy of an application, we tend to think of things as very simple. You have the API that everybody calls, and you might have a couple of different clients. Once your application starts to grow, you maybe have different APIs that things are reaching out to. And if there's only one server that is managing those user tokens and keeping track of which ones are valid and which ones are invalid, for example, the authorization API might be taking care of that. When a user then calls the search API with that same token, the search API is then going to have to call the authorization API to see, is this token still valid? Now, these milliseconds, of course, add up. And we could try various different things to sort of synchronize the validity of tokens across different services. But there's a more stateless way that we can do this. And here's an example of how that would do. So a user would call the search API. It would contact the authorization server, which get a response. And the same thing would happen with one of the other APIs. So a more stateless way to do this would be something called a JSON Web Token, or JWT for short. And so a JWT is just a string that we see here in the box on the left. And it is comprised of all ASCII symbols. And there are 3 sections to the JWT. The first section is going to be a header, which describes that it is a JWT and the type of algorithm that is used to sign it at the end. The second section is the actual payload of the JWT, and this contains all the pertinent information about the JWT, such as who it's for, how long it is valid for, and maybe who issued that particular JWT. And the last section is going to be the signature of the JWT. So what happens is you can see that these are just JSON strings in here. And to sign that, we're going to do a base 64 encoding of those 2 strings there, concatenate both of those with a period. And then in this case, this particular JWT is using a HMAC SHA-256 signature on there, and it's going to come up with the hash for that particular string, and it will base 64 encode that, and then that will be the third section of the JWT. So what that means is, because this has been signed with those particular payloads by the server that issued it, if someone were trying to modify anything in this token, just even 1 byte in there, that would mean that the signature that would get calculated on it later would then be different. So if a server were to accept this and see that the signature that was provided does not match the signature that it recalculates when it receives the JWT, it would know that the JWT has been tampered with, and it would reject it. Also, JWTs always start with EYJ, because that's how a opening curly brace starts off with in base 64 encoding. So you can, if you look in your session storage in your browser, you'll often see a lot of these in here, and you'll see that you can then decode this. This particular decoder is a free website, jwt.io. You can paste JWTs in there. One of the things I like about it, it's all written in JavaScript, so it doesn't actually post your particular token onto a server. And so you can, I use it frequently at work to make sure that things in a JWT are valid without having to reveal personal information to a third party. So with a JWT, just like a user token, we have the identity in that token, so you're going to know exactly who it is that's making a request on there. Another thing is that we could assign these to both logged in users and unknown users. So for example, the first time a user visits the website, in the background, we can just give them a jot without a user ID. And so that way we would know that that particular device would be valid for that particular validity period that we assigned in there. And we at least know that it's an unauthenticated user making those requests. A jot is going to be time limited. That is one of the requirements for a jot, is that you have both a timestamp in which the jot is not valid before, nor is it valid after. And so it really depends on the application how long these jots are going to be valid. Sometimes it can be a couple minutes. Sometimes it can be several hours. In some cases, for a machine-to-machine API, it could even be a few days. The downside about a jot, though, is that you can't revoke one. So because the jot itself describes that it is valid, and each particular server that is decoding this is going to look and see if the signature matches and then treat it as valid, there's no central authority for anything to go in and look up and see that this particular jot we would consider compromised and we don't want to consider them valid anymore. So this becomes somewhat of a delicate dance where you have to decide a time window that's both short enough that you can keep them not out there for too long, but still long enough to not annoy your users for having to re-authenticate too often. Although I say you cannot revoke one, you can technically revoke them all. Now, each jot is signed by a private key that the authorization server would use, and then each of the other servers that you would send that to has a copy of the public key. If you then decide to use a different public key to look at all of those and a new corresponding private key, that would mean that every single one of the jots that's currently valid that's out there would then become invalid. So if you were under heavy attack, this is something you could potentially do to kind of sort of stop the floodgates, at least for a short period of time. But just remember that it is not really possible to revoke a jot. Once it's out there, it's valid. So like I said, when a jot expires, there's a couple things you can do. Probably the most popular thing is to force them to log back in again, much like if you had an expired cookie. Another thing you can do is use a refresh token. And a refresh token is something that is issued by the authorization server at the same time as when the jot is issued. It looks a lot like a jot, but it has a special type of payload that identifies that particular user. The authorization server is going to keep track of the refresh tokens that it has issued, who it is issued to them to, and how long that token should be valid for. So that way, if the client notices that their jot is expired or is very soon to expire, it can then reach out to the authorization server with that refresh token, and the server will then provide it a new jot without their user having to re-authenticate themselves. So also a jot, you can put pretty much anything into it since it is just a JSON object. In this particular one, we're storing the server that authorized it, and it is what I would call an anonymous token because there is no subject or username associated with this. But we notice this key in here called audience, and this will tell the various different servers who this particular jot is valid for. Now, let's say in this application, it's possible for an unauthenticated user to talk to both the search API and the map API, but maybe they can't talk to the purchase API because they're not authenticated yet. So because we didn't add that API into this list, we'd know that when we sent this particular jot to that server, that it would not be valid on that server and that they would need to go and get a new jot for that reason. But just because we have a valid jot, we're kind of running into the same problem again in that we can just continue making requests over and over again. Sure, the company might know who that user is belonging to, but with that same jot, we can just call that user 123, 124 again. So is there a way that we could make it harder to get to those particular requests? And in the same way that we can sign a jot, we could also sign a request. So we'd use that same HMAC method to actually sign the payload that the user would be sending up to the API. So for example, if we were to have this same get user call, inside the application, you might have an API key and an app ID. The app ID would probably be something limited to a specific installation of the app or a specific version of it. So that would change every time there's a new update in there. And so once we had that request in there, on the client side, it would then take these same things and sign them and come up with a signing code. Server would get that same request. It would take the three inputs, the URL, API key, and app ID, and it would run that through the same algorithm and make sure it gets the same thing. So that way, if someone tried to change it to get users 124, it would not be a valid request, and we would consider this secure. This is a very, very common use case with static resources, especially images. And usually what happens is the server would then be signing this URL instead of the app itself. So if you've ever looked closely at an Instagram image, you'll notice that it has a signature in the URL and a expiration timestamp. And so before allowing anyone to access that image, the server is going through and calculating that signature and giving it out to the user. And this, I think, will prevent a lot of hot linking for Instagram images. And so it means that after a certain period of time, that URL is no longer going to be valid, and the user is going to have to re-authenticate with the API or the web page that generated it to get a copy of the new URL. So if we are doing this on the client side, it does mean that it is possible for someone to go and find that signing key so that they could potentially go and sign more requests for the different URLs that they might want to access for. So if you have access to the app's source code, which you would in a browser, and potentially could if you were able to get it through the mobile app, you could just look around the source code for that API key. In the web browser, you could set a breakpoint just before it makes that HTTP request, and you could kind of see a stack trace of how we got there, and you might be able to find that method that does contain that key. Another fun one to do would be to look at the app's console, like the developer console and the web tools, but also mobile apps do log out to another sort of device console that is very easy to get access to and also very noisy on mobile devices. And sometimes, developers, as they're troubleshooting, they put debug statements in there, then forget to take them out before the app goes to production. So you could have the signing key leaked there. Another way around this is to make the signing key dynamic. So that's not just a static key for every single app in the instance. Because this is something that would be calculated rather than declared, it makes it a lot more difficult to find in the code because you're not just searching for a string, you're having to find an actual implementation of some sort of method or a class. You would need this to be a deterministic algorithm so that the server can then duplicate the same thing. So as an example, we might take the string length of some class that's part of our application, concatenate that to the version number of the app, and then the date and hour of the timestamp in UTC. And so that way, every hour and every version that the app is updated, this signing key would then be changing and regenerated. Also, like I said, that we might have access to the source code. You could connect an app to a debugger. And in the browser's JavaScript console, this is quite easy to do. But it is also still possible for a mobile app, even if you don't have the source code to it. Android apps also are very easy to decompile and actually decompile quite readable if they're written in Java or Kotlin, to the point where you can see all the class names. Sometimes they do get obscured a little bit, but you can at least see all the methods that are being called and some of the source code that is in there. This does work on iOS too. I don't have any experience doing that, but I know that that is one of the things that is really popular amongst jailbroken devices. So rather than trying to have and sign all our keys from the app, we could instead proxify all our calls to the API so that our app only has one secret instead of many different secrets to talk to different APIs. We would then have the proxy verify that secret, and then it itself would reach out to the other actual APIs on the user's behalf. This is especially useful if you're integrating with third-party APIs. For example, on Google Maps' geolocator, they're going to give you a static API key that is going to be used throughout your application. And anyone who then had access to that API key could then continue to call that API, and that could potentially cost you money in the long run because each of those API's calls have a cost associated with them. So by processing that through, you're not actually exposing the API key to any of your app users. And it also makes it easier to rotate if, for example, that key got compromised on GitHub again. But it does still mean that we are dealing with a secret. So is there a way that we can have an app work without a secret in it? I promised an OAuth 2 flow in the abstract, so here we go. So we start off with our app, which would then make an authorization request to an OAuth 2 service. This would be an authorizing the user type of request. That would then talk to our API gateway, which then talks to our auth service, which would validate that the user is good, send them back, and they would get an auth token. From there, we would authorize the app. And by this, I mean the sort of dynamic instrumentation check and seeing that the app is running in an unmodified environment. We would do some checks on that to make sure everything is hunky-dory there, and then they would come back with an app token. So now the mobile environment just has these 2 tokens that are not stored on the device at all, but could then be used to make API calls through the API gateway to all of our APIs that are then proxied behind it. And so in this, say we're authorizing both who and what, the user and the app, instead of just one. That token that it would be returning would be something very short-lived, so that we would be able to monitor the continuing usage of those and how often they are being generated. And although I do say OAuth 2 in there, and that is typically used for user authentication, don't think about this so much as that, but more of an access token generator. Also, because all of our APIs are proxied behind that one proxy, it means that we can rotate all of our secrets without having to issue any updates for our mobile apps. And that API gateway, of course, can do some rate limiting and authentication checks for us, thus meaning our applications have a lot less to worry about, and they can concentrate on just dealing with the API calls that they have to deal with. So sometimes you have endpoints that can't necessarily have authentication. So I can think of maybe a website that has a storefront on it, and users can go and browse the catalog in there. Obviously, you don't often want users to have to log in to be able to browse the products that are for sale, so you wouldn't want to have authentication required on that. But that doesn't mean that the API should just accept any old request without any sort of authentication. Like I mentioned before, when the user first visits the website, we could give them an anonymous jot, and then we can have some information about who that went out to. We can also do rate limiting on these APIs that can't have any authentication. And this is another one of those rare instances where we actually have some insight into an attack that would happen. And this was back in 2018, and T-Mobile had to admit that about 2 million of their customers were subject to a data breach. And we noticed in here a couple of key things that the cybersecurity team detected, which means that they had a rate limiter on this particular API, and someone was monitoring it, or there was some automation around it that noticed, hey, we're getting an unusually high number of requests to this particular API. Someone needs to look at it. So in the middle of that, they were able to shut it down, so only 3% of their users were actually leaked instead of the 100% that could have been. So like I said, monitoring is a very important part to that, to make sure that even if your authentication is compromised, that it's not going too far. You can use some heuristics based on these to kind of see how often requests are coming in, to see, does this traffic look really similar to some other traffic just because maybe some parts of it have changed. Often rate limiting is based on an IP address, and so an attacker will get access to some proxy servers to then kind of get around that, so make requests coming through several different places, which is the foundation of a DDoS attack. So you might want to look at how similar the requests are to each other, time between requests, and maybe some information about them, like where that IP is coming from. And again, I mentioned API gateways. Some of these can do this out of the box. So maybe you've heard too much about APIs and you said, we're not going to do this anymore. Just having JSON endpoints out there is just way too much for us to handle, and people are just going to use that and see that as a thing to attack. So we're just going to go back to straight web pages and have everything available there. Well, our old friend curl is still of use here, and with a couple of curl calls and some regular expressions, we could probably extract some information out of any web page. So you think, okay, we'll put static in the HTML. Maybe we'll put some JavaScript around it, and we'll really obfuscate it so that they have to actually load the page in a browser to do it. Well, what we can do then is we could use Symfony Panther or some of the other browser testing devices, and with just a couple lines of code, we could log into that service and then read some text on the web page. And you say, well, we have a CAPTCHA on the login page. We're not going to get robots logging in. Well, I was actually floored when I found out that there are actually APIs where you can send in the CAPTCHA and it will solve it for you. They're kind of hush-hush about how this works. Some of them will, some of the more simpler ones will do optical character recognition and sort of read the text in there. Some of them, when you have to choose the buses or the bicycles, they might use some AI to try and get around that. But I know that some of them still actually use humans that will sit there and they're waiting for a request to come in, and they will click the things for you and then send back the token that you would then forward back on to get around that CAPTCHA. So in conclusion, just remember that dumping a database through an API is significantly easier than trying to hack into someone's service and dump their database over SSH. So that means that your APIs are going to be probably the primary attack vector that someone's going to look at to get access to your data. If they want it bad enough, they're going to try hard enough to get it. So we talked about several different methods for authenticating, especially with a double-legged OAuth 2 flow. That might be very complex for something that's not really that valuable and might not be worth implementing. Definitely only want to reveal what the current user needs to see. If they shouldn't see someone else's data, don't let them access other person's data. Don't use static authentication like API keys. Debug protection and code obfuscation can thwart semi-determined hackers. So I know that we talked about the request signing in there. There was one that I saw that someone had put the AES algorithm in JavaScript. It was very heavily obfuscated and packed in there. And I ran through it with a debugger, and I think after about 10 steps, I realized that I didn't actually want access to this API anymore, and that they had sufficiently thwarted me from trying to get access to that. And in where it's possible, you can authenticate the app and the environment, as well as just the user themselves, so you can see where your requests are coming from. If you want some more information about this, the OWASP API Security Top 10 is an excellent resource for talking about everything that we talked about here and more. They put it in much more jargony terms. For example, I think it's, I don't even remember the acronym, a broken object level authorization, I think is the term that they use for user A can see user B's data. So this is a list of things to watch out for that was released in 2019, and interestingly I note that as of 2 days ago, they've started writing the 2023 edition, so definitely watch this space. If you're more of a book person, there's a Hacking APIs book by Corey Ball, which is available on No Starch Press. He definitely talks about the OWASP Top 10. It's going to break it down into much more user-friendly terms than the jargony OWASP list will. Portswigger, who develops an application called the Burp Suite, has a web security academy, free online training with some labs that you can do, and you can actually see a lot of these methods in place and actually replicate them on your local machine without having to go and attack someone else's API. And if you're more interested in some of the sort of app dynamic integrity checks, I would take a look at the OWASP, let's call that MVASIS rules on there that talk about how that's implemented. With that, I'll go ahead and open it up to questions.
We have a microphone if anyone has a question. I'll go here. If you could pass that down, and I'll come to you next.
Probably just shout it. Do you have a recommended capture kind of solution that you would use, or?
So I'll repeat the question for the live stream, asking if I have a recommended capture solution.
Yeah.
I don't.
Okay.
I think if you're worried about people automated bypass of them, I would go out and look at several of the popular APIs that will then do the solving for you and see what they support. Like some of them might support HCAPTCHA, but not the Google CAPTCHA, and so then you might think that the Google one could be more secure.
Yeah, it goes onto the live stream, so it's worth. That's all right, no worries.
Hi. So what do you think about as the JART isn't possible to revoke, to let a user authenticate and get like a JART, like for example over OpenID Connect, and then replace it for like API calls with a self-generated key which you can revoke? So
So it's almost like you would be hashing your JOT and making that an API key. Is that in a roundabout way? Yes?
Not necessarily, but
Okay.
yeah.
Not necessarily hashing, but still using something based on the JOT to use that as an API key.
Yeah.
I would say as long as you can then uniquely identify that that key is one particular user or instance or installation, then you're effectively accomplishing the same thing.
Okay. Yeah. Thanks.
Mm-hmm.
Anybody else?
Right, thanks for the talk. So you talked about not encoding API key and sending that because obviously you can sniff the API key and then you can use it. But if you use auth2, you have to obviously create the token and then you pass the bearer token in the header. So it's kind of the same thing anyways. It's just instead of having API key and, I don't know, URL, you have a bearer token in the header and you can still snip that out and doesn't change anything in the end.
True. It really depends on what you put inside that header. And so there's nothing in the spec that says that a bearer token has to be a JOT or any sort of token that is time limited. You could put a static API key in there. So the important part would be something that's not given out to multiple users so that anyone could then grab it and use it for whatever they want. Does that answer the question?
Any more? I think we're good. Thank you very much.
Thank you all for coming.
5 minutes yet. Just slowly get more nervous. I have got one of these watches that does my heart rate. And yesterday, I did a talk yesterday, and I looked at it in the evening, and it'd been like I'd gone for a run. It'd been like that. That's how scary you are. Yeah. So, yeah, I'll tweet it later. Yeah. I said abstract syntax tree. Who's heard of an abstract syntax tree? Who knows a bit more about it than just they've just heard of it? Excellent. Hopefully by the end of this, you'll know a bit more about abstract syntax trees. Anyone had positive experiences with static analysis? Made their life easier? Just one person? A few? Anyone had some terrible experiences with static analysis? Oh yeah, there's one there. We've already tried to fix that one, haven't we? Yeah. Yeah, I think it's great, actually. It just finds... I was using it on a project, and it found so many bugs. It was just amazing. Well, obviously, I should code better, but it was yeah, really useful. If you're not using it, I definitely recommend using it. On the audience, are you okay? Hmm? Oh.
You can come up to about here. Yeah, you can do a little bit of strolling. Okay, is this working? Hello. Hello, everybody. Next up, we have the return of Dave. He's very kindly stepped in to fill a space in our schedule. So I'll hand you over to Dave now.
Thank you. Excellent. Right. Extending the PHP language with static analysis. This is one of my static analysis, and what we can do with it is one of my favorite things to be talking about. So thanks for coming along. I think these tools are incredible. Hopefully by the end of this session, you'll think that as well, and maybe you'll have some great ideas about how we can make PHP even better using static analysis. So let's start with a question. Have you ever thought to yourself, if only PHP had some language feature that another language has got? Or maybe you're thinking, I've got this great idea for PHP, if only it could do this. And this is a story where I had similar thoughts and how I built these new language features with static analysis. So it's a story where I started off with a very specific constraint, and then I moved it to something that's more generalized version that is useful in my project, but it might be also useful on your projects as well. I think ideally, you've probably at least heard of static analysis, and maybe you've had a play with SAM or PHPStan. That's probably quite useful. If you haven't, hopefully you'll still get something out of it. But I think if you've used these tools or you're using these tools, that probably puts you in a good position for this talk. So there's a few. I think there's 3 seats at the front there, just down there. And then we might have another one here. I mean, I actually have. I can start again if you want. I didn't realize we have so many people. Wow. That's right. What I might do is I might just go back to start for the people who've just arrived, if that's all right. Yep. Sorry, it's my fault. I started early. My bad. You made me start early. It's his fault, yeah. Thank you very much. Wow. The people next door think, has he finished already? Okay. Have you ever had a thought, if only PHP had some feature from another language? Or maybe you thought, if only PHP could do this. This is my story about how I built some new features for PHP using static analysis. And I started off with something that was a very specific constraint. There was a very, very specific problem that I was trying to solve. And then I extended this to a more generalized version, and maybe this will be useful on some of your projects. You'll probably get most out of this if you've used SARM or PHPStan, but if you haven't, there might be a bit in the middle that might be a bit tough going, but stay with it, because at the end I talk about things which is kind of appropriate regardless of whether you've used these tools or not. So I'm going to talk through, this is just one example I had, and it's one of many, and probably on your projects you might have a problem similar to this, or if you think about it, you'll have things that are kind of like the same, the same kind of concept really. I have some code, and I want to send a text message. So I've got some text message sender code, which is the red box, and there is a send message method on the text message sender class. Now, sending a text message relatively is quite a slow process. It requires an HTTP request. That might fail. We might have to retry. So I don't want to be calling this code from anywhere in my code base. Instead, when I want to send a message, I want to call the send message method on the text message gateway, and that we'll put it into the queue. Then we have a queue processor, which takes things off the queue processor, and then it then calls send message on the text message sender. So this is pretty standard for anything that's relatively a slow thing to do. So I just want to enforce this constraint so that I don't forget, I don't accidentally call send message on text message sender from anywhere other than the queue processor. So how can we do this in PHP? What I'm saying is if I do call it from text message queue processor, that's OK. But if I call it from any other part of the code, this is not allowed. Now, if we think about our visibility modifiers in PHP, we've got public, protected, and private. None of these are really suitable for this application. There's nothing that's quite the right level of visibility. So we need to do something more. And just to reiterate, the reason we're doing this, the reason I want to automate a check for this, is because it means that either me in the future or other developers coming onto the project won't forget about this constraint. We don't have to remember it in a year's time or 2 years' time. We don't have to pick it up in code review because we can just automate these checks. So this is the problem that we're going to solve by the end of this talk. And you might have similar problems to this, or you might have things that, you might have a very specific problem that's just like this, or you might have similar ones. And I think if you think about it, what we're doing here will be applicable to many of your code bases. So the journey we're going to take, we're going to very quickly look at something called the RFC process, which is one way that new features get into the PHP language. Then it's a bit of a deep dive. We're going to look at the AST, the abstract syntax tree, and a PHPStan rule, okay? That bit, quite technical. If you get lost on any of that, just wait until we come up to the peak and the PHP extension library, and then we'll finish with some thoughts. Okay, so the RFC process. PHP is open source, so anyone can contribute, and the way we contribute to get new features is we create something called an RSC, a request for change. And it's got a very specific format, and what happens is you have your idea, you create this document, so you first write your RSC, then you have a polite bit of chit-chat with all the people on PHP internals, then you have a vote, and if 2/3 of the people who are eligible to vote and think this is a good idea, it will get implemented, and then eventually it ends up in the language. Realistically, this is quite a long process, and rightly so. This isn't a criticism of the RSC process. It takes a while. I mean, I think if you had a relatively simple idea, and we only get PHP released every year, so probably the minimum time from idea to it being released as part of the language is probably 6 months, and that's if you pick your timings right and all the stars align. In reality, this is probably a longer process, and a lot of the features, sometimes they fail at the first time, and then people go round again, and it takes several iterations. So this could be like 3 or 4 years before some features make it into the language. But the great news, there is another way for some functionality. And the way is we can do static analysis. So instead of executing code, we can analyze it beforehand. So if we look at this code here, if we executed it, it would fail on this line here, where we're calling the update method on person. If we run it, we'd get this uncaught error, call to private method, person, : update. But we don't have to run this code to see there's a problem, because we've all looked at it, and we can see that there's a problem. So analyzing code and not running it, that is static analysis. And if we use tools like PHPStorm, or other IDEs, or SARM, or PHPStan, they will all look at this code, and they'll say, I can see a problem with it. So this is how we can use static analysis to find issues. And in terms of new features, using static analysis, we already have generics as part of the language. So if we look at this code here, we are iterating through whatever we get from the getPeople method. We can see that the getPeople method returns an array, and from the dot block, we've provided additional information to say everything in this array, the values should be of type person. So that means when we call process $person, we know that $person will be of type person, and then when we try and call the process method, it's expecting a car. A person isn't a car, so static analysis will tell us you've made a mistake. Okay? We don't need to run this code. Static analysis can tell us we've made a mistake. So if you're not already, even if you don't want to extend the language, I strongly recommend you add static analysis to your development process. So you write code, and before that code gets deployed, you run static analysis. Ideally, well, definitely as part of your CI, but ideally as part of your process when you're developing locally. And you might say, this is great, but how does that help us get new rules? Well, we create custom rules to emulate new language features, and that's what we're going to do. So this is how we can extend the language with static analysis. We write our own custom rules, we add them into part of the things that the static analyzers analyze, and then we have got essentially new features, and they are validated at static analysis time. So that's the setting, really, of this story. Before we can write our own rules, and I'm going to talk about how to write a rule for PHPStan. It will be similar for SARM. I only know how to do this for PHPStan, but I think it will be similar for SARM. Or these concepts will be the same. But before we can write the rule, we need to understand something called the AST, the abstract syntax tree. When you've got your code, it goes through several steps before it gets executed. So we've got our PHP code. It goes through a tokenizer phase, which I don't really know much about. The tokens are then converted into something called an abstract syntax tree. Then the abstract syntax tree is used to generate opcodes, and then the opcodes are run on the PHP VM, and that's what happens pretty much every time you execute some code. You run some PHP code. And the bit we're interested in is the abstract syntax tree. So the AST, the abstract syntax tree, is a tree representation of your code base. Any PHP code you write, you can represent in the abstract syntax tree. And the AST isn't specific to PHP. Many other languages use this kind of concept as well. So if we've got some code like this class called person notifier, the AST is made up of several nodes, and each node is of a different type depending on what it is representing. So we've got a class, so this is something called a class node, and then they might have properties. So we'll come back to this. It's got flags as a property on it, which is set to 0. We'll look at flags in a bit. And this has we have some child nodes. One of them is an identifier, and so the class has got this property name, and it's got an identifier node, and that has its own property, which is person notifier. And then class also has a number of statements, and we've got 3 statements, high-level statements in this class. So we've got the property, and we've got 2 methods, the constructor and the notify player method. So hopefully you can start to see we've got our code, and we've got a visualization of it in a tree-like structure. Now, if we look at the notify player method, we've got a class method. That in itself has a name property, and again, that's an identifier, and the identifier has a property which is notify player. We've got some parameters. This case, we've just got a single parameter, which is string, and then internally, this has just one statement, which is a method call. So the key message I really want to take from this, and we're going to look at some AST again in some of the examples, is we've got our code and we can represent it in this format. And there's a library called PHP Parser, written by Nikita. And if we ever need to do any analysis on this is the PHP representation of the abstract syntax tree. It's not actually used when we execute code, because that's all done in C. But if you want to do analysis like we're going to do, you can do this using this library. So the key takeaways is PHP code can be represented in an AST. There's different types of nodes. The nodes contain information about what they represent, and each type of node will have different information and different child nodes and different properties. So that's quite a high-level overview of the AST. We're going to keep referring back to it. But that's kind of just what I want you to take away from it so far. So let's create our first PHPStan rule. PHPStan is one of the static analyzers, and it has many, many rules. And when it analyzes your code base, it just goes through the code and tells you of any violations of these rules, and we're going to make our own PHPStan rule. So what PHPStan does is it iterates through your code's abstract syntax tree. It moves through it node at a time, and each node it visits, it says, I've got a class node. Are there any rules that are interested in this? And someone will say, yeah, me, and then it will pass off the node to that rule, and it will do some analysis on it, and either it will say, here's some issues I found, or it will return something and say, I haven't found any issues there. And then it will move on to the next node, and the next node, and eventually it's visited your entire code base, and it tells you all of the problems it has found. So to create a PHPStan rule, you need to provide an implementation for PHPStan's rule interface. And this requires the implementation of 2 methods. The first is getNodeType, which is pretty easy. And the second one is processNode, which is a lot more complicated. ProcessNode returns an array, and if it's an empty array, that means there are no errors. This particular rule hasn't found any issues. Otherwise, it returns an array of 1 or more issues that it's found. So let's create our first rule. But before we do it, let's remind ourselves what we're trying to do here. What we're saying is we can only call methods in text message sender from the text message queue processor. So we can only call the red box from the yellow box. Anywhere else in the code base, we don't want that to happen. So the node type, for our rule, we've got to say what type of node we're interested in. We're interested in code that looks like this. We've got this sender, send message, and that is a method call, okay? So we're interested in method calls, and a method call has kind of three parts to it. It is the variable you're acting on. So in this case, in this code, it's this $this sender. Then it's got the name of the method. In this case, it's called send message. And we also have any arguments we're passing to this method call. And if we look in the Nikita's PHP parser library, and we go and find the method call, at the top of it, there's these three properties, three public properties. There's the var, the name, and any arguments we're passing to it. So when we're trying to create rules, what we're trying to work out is what type of node we're operating on in the abstract syntax tree. And here we're interested in method calls. Then when you're new to this, often you're referring back to the PHP parser library, and you'll find the method call node, and there's lots more to it, but actually normally you just look at the top and you see the properties, and that's enough information to kind of to get you going. So we're going to create our rule. We will call this rule the text message sender caller rule, and there is a pint for anyone who can think of a better name for that later. So we'll implement the first method we've got to in the interface. We're saying, what's my node type? We're going to say we're only interested in method calls. So we return method call class. And then we've got to implement the process node. So what happens in the process node is PHPStan's going through its code base, and it's found a method call. And we need to see, is this method call something we need to warn people about? So the first thing we're going to do is, so what gets passed into is a node and a scope. So the node is the element in the abstract syntax tree, and the scope is a bit of additional information that PHPStan gives us in the context of this particular node that we're looking at, and then we return an array. So the first thing we're going to do is we need to know the calling class. And we get that from the scope. So what happens is, when we get to a method call, that method call could be called, that could be anywhere in the code base. We need to know additional information about it. So if we look at, imagine we had a person notifier class, and we've got this method call, this sender send message, then this sender is called from person notifier. So on this method call, the class we're in is person notifier. So our calling class, if it was like code, if we were talking about the node on the previous slide, we know that calling class is person notifier. So the first thing we can do in the rule is saying if if our calling class is text message queue processor, we'll just return an empty array, because that means, if we think about this, that means any method, so any call from text message queue processor is allowed, okay? So because we're only interested in finding calls to text message sender that are not from text message queue processor, if our calling class is text message queue processor, we can just exit this rule and say, there's no errors here, there's nothing to worry about. So that's this logic there. Does that make sense? That's pretty good. We are at 3 o'clock, and this is quite heavy going, I think, so well done. So the next thing is we need to know the type. So as a quick reminder, we've got the variable, the name, and the arguments, and we need to know the type of $var. So we need to know what this sender resolves to. So if we look at some code, if we've got a property text message sender, and then we're calling this sender send message, then this sender is of type text message sender, okay? So we're trying to get the type of whatever our node var is. So we're trying to work out the type, what class we're calling send message on. So that's what type is. And then now, type can be anything. It could be a primitive type. It could be, or it could represent a class or a resource or anything. So then we say, get me all of the classes that type could be. And the interesting thing here is, well, surely you might be thinking a class. Surely this $sender can only resolve to one class. But actually, in PHP, it could resolve to multiple classes. I mean, I wouldn't recommend doing this particular code, but here, this sender could either be text message sender or it could be WhatsApp sender. So there are times when a property or a variable could resolve to multiple classes. That's why when we say get the reference classes, that's why we're iterating over more than one. And then what we do is we're saying if the target class is text message sender, then we are going to create a rule that says you can't call text message sender from here. Okay? So what we're doing is we're working out, if we go back to our diagram, what's happening here is we are trying to call text message sender. That's the class that we're calling the method on. So if we're doing that, we need to tell people that this is a problem. And we know this is if we get this far, if we get to the red box at the bottom, and we are calling text message, if the class we're acting on is text message sender, we know this is a problem because if we were in the text message queue processor, we would never get this far because we have exited, and that's the code in the yellow box at the top. And then finally, if when we're going through all the loop of the target classes, we haven't thrown in exception, we haven't created any errors, then at the end we just return an empty array because this means that we haven't found any violations of this particular rule. So I'm just going to put the code up there with the comments. If you've got any questions, now is a great time for me to, if I need to clarify anything. Yes?
With that, I'm assuming that can't work if you label to be mixed.
I'm sorry?
I'm assuming that can't work if you've labeled to be mixed where you looked at the different classes?
Yeah, so if this will only work if the type information is available there. That's a really good point, yeah. PHP static analysis is only as good as the type information that we have. So if you are leaning on static analysis to do this kind of thing, then it does mean that you need to give type information to pretty much everything in your code base. That's a really good point, and I shall definitely make that clearer next time I do this. So thank you very much. Any other questions? Yeah.
What about the intersection types?
If PHPStan can work all this out, oh, sorry, right, for the people at home, the question was, what about intersection types? And the answer is, if PHPStan can work out what the type is, then all of this will work. Okay, so we've created our first rule, and it's not a huge amount of code, actually, and this will protect us from this problem that we kind of mentioned right at the start. There's a few bits of housekeeping. Where do we keep this rule? What I do, and you don't have to do this, but what I do is I create a build directory at the same level of source and test, and then in that directory I have PHPStan because maybe there'll be other tools I might be using in there, like Rector. So in the PHPStan folder, I've got my text message sender call checker rule. We need to tell Composer about this. So this is just an auto-loaded dev requirement. So I tell Composer where it can find the rules. And then finally, I need to tell PHPStan where these rules are. So in the phpstan.neon file, under the services element, I say there's a class called David Lindemann PHPStan rule text message sender rule checker, and I give it the tag PHPStan rules. So that means that when PHPStan starts, it goes and looks in its config and goes, as well as all the other rules I'm looking at, I've also got to pick up this rule as well. So I think this is pretty amazing, actually. We've not really written much code, and once you've done this once or twice, then they're not actually that difficult to create. I think this is pretty amazing, but we can do better, I think. The rule we've created is so specific, it will only ever work on that particular project for this particular combination of classes. And what we should, maybe we could make this a bit more generic. We can say, well, look, why don't we be able to configure this so we can only call methods in target class from a specified allowed calling class? Let's make this more generic. So let's see if we can do this. So the first thing we can do is we can update our text message sender caller rule, and we'll update the constructor to take two things, the allowed calling class and the target class. And we'll just store those. So this rule is constructed, and actually probably we should change the name of it now. And then the code in the process node, there's just a couple of changes. Then instead of calling class being hard-coded, we're saying if calling class is the allowed calling class, then we'll exit with no errors. And then finally, our check for target class, instead of having it hard-coded, we have whatever we set up in target class. And then there's just a few changes we need to make in our PHPStan configuration. We now need to give a few arguments in the allowed calling class and the target class. We've got to tell PHPStan what that is. So we do that in the configuration. And that means if we want to set up another one, all we do is copy and paste the configuration, and then we have our second set of allowed classes and target classes. So now we've set up a rule that's pretty much generic. It can work for any combination of this class can only be called from this class. So I was amazed before, but this is even better. We've made hardly any changes, and now we have a rule that is, can be used even on your code bases now, or it can be used on mine in different contexts. But we can do better. So actually, there are already tools that do this kind of analysis. I think it's like PHP Arc and things like that. So if you want to do this kind of, if you want to do it just as I've said there, you've got tools which you can configure in a similar way. But I think we can go a stage further. So the problem with what we've done is we need to remind people that you can only call text message sender from the text message queue processor. So one way we could do this is we could add a comment to text message sender and say, by the way, you can only call this from text message queue processor. Nobody reads comments. We've got to remember to document it. We've got to remember to set some config up. And then what happens if we start renaming classes? If we start renaming classes, then yes, our IDEs might remember to rename things, but will the IDEs change things in the config? Maybe, maybe not. So instead, what we could do is we could create an attribute called friend. And why is it called friend? Well, actually, that's in C++. They have this concept of friend, and it means that that only friends can interact with the method call. And actually, there have been previous RSCs to add friend to the PHP language, which didn't pass at the time, but maybe they will in the future. So we've got this friend, and it just has a single a constructor with a single parameter, and that's the name of its friend. So that's the class that it's friends with. And then in text message sender, we can add the friend attribute to it and say, my friend is text message queue processor. So now we've got documentation in the code. Okay, the first time a developer sees this attribute, they might ask, what is a friend? But once they know what that is, they understand what's going on here. And if we're using an IDE to do refactoring, and we refactor the name of text message queue processor, the refactoring will work. Everything will still go. So I think this is a better way of doing things. And we're starting to add like a new language feature, this friend, in attribute form, you could argue is a new language feature. And there's not really much we need to do in terms of updating, so we'll go back into our process node thing. The first thing we do is we're going to get the name of our calling class and the type we're acting on, and then we'll go through all of the classes that we're acting on. And then we've got to ask two questions. Is the target class, does it have a friend attribute? And if it does, is the calling class a friend of the target class? So we'll go back to our constructor, and we'll remove the code that we had before where we were passing in the names of the target class and the calling class. And we're going to pass in something called a reflection provider, which is provided by PHPStan. And let's go back to the code. The first thing we're going to ask is, does the target class have a friend attribute? And this is where we need the reflection provider. So PHPStan knows about the node, and it has all context for the node that you're looking at. But if you need to ask about other bits of the code base, we do that via the reflection provider. So what we're going to do is we're going to say, get me information about the target class. Then we're actually dropping down to PHP's native reflection, which we need to do because at the moment, PHPStan doesn't have its own analysis of attributes. We just use PHP's native reflections. What's really going on here, don't worry too much if it doesn't really make sense. What we're saying is we're looking at the class, and we're saying, does it have a friend attribute? And if it doesn't have a friend attribute, then we exit this iteration of the loop. And if it does have a friend attribute, then we get the first argument passed in to the constructor of the friend attribute. We just got a guard here to, if somebody didn't set this up with a friend, then we just again exit out the loop. And then finally we say, is my friend? Finally, I then get the name of my friend. So basically, if we've got this far, it means the target class has got an attribute, and we've got the name of the friend, which we store in friend class. And then all we need to do here is say, is our calling class, is it a friend of the target class? We do a comparison, and if they're not the same, then we say, you can't call this because you're not my friend. I'll share with you the repo where you can look at this again if you want to digest it in a bit slower time. What I'm going to do now is I'm going to show you a slide with all of that code on. So that is the attribute, and this is the code. I don't expect you to be able to read this here, but the point is, it is not much code. If you're sitting at the front and you've got good eyesight, you could almost read this. It does not take that much code to create the friend feature, a brand new feature. If you want to see it, that's the GitHub repo. I think this is mind-blowingly amazing. I think this is incredible, right? We can create what essentially is a new language feature in what would be a couple of hours of work. And if you compare that to the RFC process, it would be a much, much longer, and rightfully so, but it is a much longer process. So we don't have to do much, and we can create whatever, well, not whatever, we can create quite a few new language features. And with custom static analysis rules and attributes equals new language features. So I think that's pretty cool. And it's because we've got such amazing tools like PHPStan that allow us to do this. Anyway, if I lost you in the deep dive, that's it. That's all your heavy concentration you need to do. It's much easier from now on in. So what I've done is actually I've created something called the PHP extension library, which uses this kind of concept that we've done. So it's in GitHub, and there's a couple of parts to it. There's the PHP language extension, and that just defines the attributes. So we've got friend, got package, injectable version, test tag, and sealed. And I'm kind of developing a few more as we go along for things that I find useful. So the definitions live in this package. And what I've done is I've split them up. So if you're using PHPStan, then you want to use this extension, and that will do all the validation. Well, that has the rules that kind of implement, the additional requirements from the PHP extension library. And I've separated them out. So if people have got other static analyzers like SARM or PHP Storm, we've actually got a whole generation of people now working on static analyzers written in Rust. They can create their own validation for this. So that's why I keep the attributes in their own separate library, because then it means that even if I don't want to support implementation of it, other people can. So the friend attribute, we kind of saw actually quite a simple version of the friend attribute. The one that's created here is a bit more powerful in that you can add them to methods as well as classes. And a typical use case for the friend attribute is things like builders. So for example, maybe I have a builder or a factory, and I want to restrict the construction of objects so it's only done through the builder or the factory. So what I can do is I can say person, the construct method is a friend of person builder. That means I can call new person as long as I'm in person builder. So that would all be okay. But if I tried to construct a person from somewhere else that's not inside the person builder, like here, another class, then PHPStan would say, no, this is not allowed. And friends can be added. You can actually specify multiple friends, and you can have friends on methods and classes. And then if you've got a method and a class, then it'll add those two together. I've also created package, which is a bit like Java's package level. So this kind of sits somewhere between public and protected. And what this means is you can only call methods from the same namespace. So typically, a use case for this is maybe you've got lots of code that collaborate closely with each other, and you might have one bit of it which is kind of available to the wider code base, and the rest of it is just, you should only be called by each other. So imagine we've got a price calculator, and then that makes use of a discount calculator, and we say that the discount calculator has got package level visibility, so it can only be called by code in the same namespace, in the shopping basket namespace here. So that means it's all fine to call discount calculator from price calculator, because they're both in the same namespace. But if we tried to call it discount calculator from some other namespace, then again, our static analysis would tell us off. We'd say, look, we're not in the same package. So that's package. Test tag is an idea I got from, so I did an electronic engineering degree at university a while back. And when they were testing integrated circuit boards, what they would do is they would have special pins on there, so you could get kind of like intermediate values, or you could put signals on the pins to put things into a certain state. And sometimes in testing, I think that is quite valuable. Sometimes we either want to add a method which should only really be used by test code, or sometimes what people do is they try and do clever things to expose or access what is like private or protected data. Now, I'd rather we had public methods and we annotated them, or we add the test tag to them, because that means to other developers, they can look at it and go, all right, this is clearly only here for testing, but it's not safe to remove. Or if I rename something, then I know there's a consequence in my test code. Whereas if you're trying to do clever things to kind of break through visibility, then if you go and change like a private variable, suddenly your test might fail for reasons that are not obvious. So anyway, this is test tag. Not everyone will agree with test tag. Maybe not everyone will agree with some of the things I do. But it's here if people find it useful. So if we try and call setID, so actually setID would be a use case if you've got a doctrine object and you've got something that needs the ID to be set. Normally that's set by the database. But if you're doing a unit test, you don't want to connect to a database, but maybe you need that ID to be set before you can do a test, or there's some element of testing that requires that. So we could put the test tag on the setID method, and then as long as we're within our tests, then that's all fine. But if we try and call our test code from somewhere else, then again, our static analysis will tell us off. And there's a couple of others I've done. There's this thing, injectable version, and this is for dependency injection. So what you can do is you would say, if, for example, you've got something in interface and then many concrete implementations of it, for dependency injection, you should be referring to the interface. So what we could do is we've got this emailer, and we put the injectable version attribute on it. And then what this does is it goes through and looks at all the constructor calls, and it works out all of the types of all of the parameters. And if, in this case, we've got emailer, so it looks at emailer and says, oh yeah, emailer's got an injectable version on it, but that's fine, that's okay. But if we, so that's all right, but if we have something that implements emailer, like PHP mailer, and if we try to inject PHP mailer into something, then what would happen is we look at the constructor, we say it's got something of type PHP mailer, we look at PHP mailer and say, well, that implements emailer, and emailer has got the injectable version on this. So we've got the wrong type declaration. We should be using emailer, not the more concrete version of it. So in this case, static analysis will tell us off. Anyway, if you're interested, have a look at it. The attributes are defined in the top one, the PHPStan implementation, the second one down, and others are welcome if you want to write plugins for SARM or PHP Storm. If you go into the file, the repo where the definitions are, we've got a source directory, which is where all the attributes are. And then we also have an examples directory. And for each attribute, we have like a series of example code, and it says this is where you should find problems. So if you're developing, like say a SARM or some other thing, you can look at this, and this would form your test set. And if we ever were going to debate how something would work, then actually what we would do is we'd create example codes here, and the discussion would be on here, and then finally we could go away and do the implementation. So this is like the definition of how your static analyzers should validate whether these things are done correctly. Okay, I just want to wrap up with a few thoughts. If we think about the kind of RFCs that we get, they're roughly these kind of groups. We've got security ones, so those could be, in PHP 7, they added a load of new security, they upgraded the security things. You've got RFCs, which are like syntactic sugar, so constructor promotion would be an example of that. It's not adding anything new to the language, it's just making it a bit more usable. You've got performance ones, things like the JIT. You've got new features, things like enum, I suppose. And then you've got things like communicating intent. And we'll look at that in a moment. And a lot of RFCs kind of probably overlap on some of these definitions. And doing what I'm proposing, it is really these communicating intention category that we can use static analysis to emulate new features. So if we think about things like visibility modifiers, if we think about things like final and abstract and read-only and type declarations and type hints, a lot of that is really there for developers. You know, the code doesn't really care if things are public, protected, or private. They're there for other developers. And in fact, actually having these things in here might slow down the execution because it's got to do additional checks. But they're really here to communicate from one developer to the other, or from you to your future self, that I don't think this, this is public, this is what everyone should be using, but this is a private method, no one else should be using that. So they're really there for developers. And if you think about friend and sealed and packaged and injectable version and test tag, they are also there for developers. They are communicating intent. There was something at the point that code was written. I'm also trying to convey that, this object, this person object, should only ever be instantiated by person builder. They're just there to communicate. And they're just there, once it's documented in a way that it's automatically checked, it means that people won't forget about those checks. We don't have to remember there's some convention there. And I don't know if this will take off, but what we could have is today we use attributes like this for the friend attribute, and we try things out, and we say, does this work? And maybe there's some refinements which we've got to try, and we can kind of iterate through this and discuss it. And then maybe one day, it becomes part of the language. Who knows? And there is actually a case where this has happened. In PHPStan and SARM, they had this return type of never. It's probably not very commonly used in code base, but it was there. And then that got added to PHP 8.1. So this idea of taking ideas from static analysis and finally implementing it in the language does happen. And the benefit is, when you do an RFC, whatever you do, that has to work forever, because once it's in the language, you can't make this, very difficult to make those changes. The benefit of doing this way is we can try ideas out, we can iterate through them, we can find all the silly edge cases and stuff like that. And actually, maybe if you do this and it's in, people are using it for a few years, you can say, when you're creating the RFC for it, you say, look, this is where it's been used, these are all the issues we've got, here's how we've ironed it out, and it's a much safer way of adding it to the language. So that's my journey. It started with, I have something that I wanted to do. Yes, I could have tried to get it through an RFC, but if it happened, I'd probably be talking about that at a conference in 2030. But instead, we can get this all done, and I can talk about it with you today. But the key things really are custom static analysis. They allow developers to communicate intent. They can automatically enforce project conventions, and we can use them to create new features, new language features. So PHPStan and SAM and this whole generation of tools that use the abstract syntax tree have given us developers incredible power. And what we do with that power, well, that is up to us. Thank you for listening.
Thank you, Dave. Are you taking questions?
Yeah, I'm taking questions.
Any questions for Dave?
I'm curious what you'd like to see from the language to further empower static analysis. So, for example, we've got the var types, so we're putting in comments. What could you envisage in the future that would give you more capabilities, kind of akin to how we have attributes on things?
Okay, great question. What I think the next... So, this static analysis way of doing things is great, but people have to be on board with it, If you are... For it to work, your project has to use it, the libraries you depend on have to use it, and if you're building something for other people to use, and you've put these things in like friend attributes, it will only work if the people using your libraries or your applications also use static analysis. What I think we could do, maybe not so much at the language level, but the surrounding infrastructure, is we could probably add more things into Composer. So we could say, when I'm developing a library, this library, in my Composer definition, uses, the friend attribute. And we have kind of a sort of definition for what friend is. So we've got an extra bit in our JSON, in our Composer, and says, uses these concepts like generics, like friend, like package. And then that would be a warning, so that if somebody uses my library, when I run Composer, or when maybe that information is then available to PHPStan or Composer, when I run Composer, it says, we should probably be using static analysis because this library you're depending on has said, I use static analysis. And by the way, it's also said it's using this friend attribute. And if that information could then be passed through to, say, your static analyzer of choice, like PHPStan, PHPStan could say, I've got this information through your dependencies from Composer, and by the way, I think you should be using this extension because one of your libraries somewhere in your dependency chain depends upon it. I probably need to write that down, but I don't know, does that kind of make sense? So, so we're adding information to Composer, which is probably the most sensible place to put this information, and then Composer, when you do, Composer install, it says use static analysis, passes the information to static analysis, and static analysis, you need these plugins to properly validate this. I think that's probably the way it can go without modifying the language. Does that make sense?
Yeah, I was thinking along the lines of there's been very, very early discussions about allowing purely annotational data.
Yeah.
Within expressions, things like giving things a type and such. And it seems like one of the issues that we have at the moment is we do have to rely on things like comments a
Yeah.
where we would, potentially get a lot more power if we put it into the parser, even if it was ignored.
Yeah.
But there's a lot of conflict in that's not strictly PHP's way with its runtime
Yeah.
checking.
Yeah. So if people were listening on the stream, they were kind of talking about, I suppose it's, yeah. Well, I think the attributes do answer the point, because that is part of the language, and any data you supply to the attribute is available in the AST for the static analysis tools. I agree that what's really missing from it is like the generics notation. There's no sensible way of putting that in to attributes as they currently stand. I did try and think about this a few years ago, and I couldn't think of a better way of doing it. So probably what we need is, if we want to remove some of the information that's dot blocks, it's primarily there for static analysis, we want to move it into an attribute-like feature, then I think you need to either have something like an attribute feature, or you change the existing attributes to support that. And I think that's another way it can, I mean, that would also be nice to be done in parallel with anything else. I think I did a gist about how you could potentially add that information in an attribute style, and some other people did some other stuff similar to that. I don't know if it's really going anywhere. I mean, pragmatically, I don't mind the information in dot blocks, because the static analyzers can read that information. I mean, it would be great if the dot blocks were only there for developers, but and it didn't have any noise for that's kind of required for, yes, it'd be better if you didn't have it in the dot blocks, but I don't think it's a huge hardship at the moment, especially because your IDEs will tell you you've made a mistake in the dot block format anyway. So you get a lot of the benefits from it, even though it's in dot blocks. I don't know if I've quite answered your question or not. Or great question, though. Yeah.
I don't need that.
People at home do.
Oh, hello, stream.
Yeah.
You said it supported multiple friends, but the examples only had one. How would that look? Do you need to list each one as a separate row? Or
Great question. Yeah, no, you can just do hash friend. Right, the example where we went through the whole code base, our first rule, that only supports one. But when I was talking about the PHP extension library, that supports multiple. You would just do hash friend, person builder, :class, comma, person factory, :class, and so on.
Nice.
But yeah,
Thank you.
good question.
Any more questions?
Dave, thank you for your talk. One of the issues I found when you're using something like PHPStan is that it's becoming slower and slower. You know, right now our code base, it's a huge code base, but it takes almost 10 minutes to run PHPStan through it. Could maybe PHP itself implement something that could help PHPStan be faster, more access to its internals or something like that could improve this? Do you think that this is something that PHP core team should look into?
Oh, that's a controversial question, isn't it? I don't actually think, in terms of static analysis, a lot of this information, well, the dot blocks don't end up in the, they sort of end up in the AST. I don't know, for static analysis, I don't know if there's much more that the core team can really do to help with that. I think this is more something that the static analysis tool vendors need to work on. And that's not a criticism of them. It's, these are like quite new tools, and they're just kind of, I suppose what they really need to see is they need to see examples where projects are quite slow, real life examples of projects that are quite slow. If you could somehow share the code with, assuming they'd be willing to accept that, to share the code with them so they can see why is this going slow. Because the problem they have is, people say this is running slowly, and how can you debug something without seeing real-life examples? So somehow you need to get real-life, slow-running examples to the static analyzer, the people who are writing these tools, so they can have a look at it and work out what is going wrong. I know some people are looking at doing this analysis in a different language, which might yield quicker results. And again, you know, the benefit of having standards for however you do things, like the generics, it's not formally written down anywhere, but everyone's kind of gone towards the same standard, and if you want to use things like this, there's a standard there. So I think that's quite important, and then it enables things outside of PHP-driven design tools to do things. So that might be another approach. I mean, I suppose actually the core team are doing, because every iteration, PHP itself gets faster, which then helps these analysis tools. So I don't really think there's much more core can do, to be honest. I can't think of any information that they could give that would help in this case.
Thank you. Any more? Well, thank you very much, Dave.
Thank you.